So let's start today's session. We are going to discuss refactoring today. Refactoring is like this. In the first case, it is very tangled, and in the second step, it's get a little better, and in the third step, it's get even better, and then it starts getting improved, and in the end, we have a straight line. So from very tangled thread to a very straight thread. Essentially, refactoring is very same. We are trying to make things simpler, cleaner, and more understandable. That's the essence of refactoring. Let's go into an instance. I was a long time back when I was hired by a software company. The first thing they asked me to do is to fix a bug. And once they asked me that when you fix the bug and you test it, then you release the version for the testing team. So I took my time to fix the bug, understand the system, and fix the bug. And then I was ready to release the software for the testing team. The problem is, since it was a commercial product, so there were 3 variants: Standard, Pro, and Ultimate. And we need to release these variants in 2 flavors: trial and release. Okay. The problem is not this. The problem is it was very large code base, and there are many conditional statements. So if this is true, then you compile this, otherwise you compile this, or otherwise you compile this, and so on and so forth. And if you want to release a standard trial version, you need to make changes in multiple files, multiple strings you need to change, multiple things you need to change just to release one variant. And I was very new to that company, so I made many mistakes. And when I made some changes to some places, and then I have given the software to the testing team. The testing team reported lots of bugs. This is a trial version, but the string which is appearing is a release version string, or the version at this dialog you are showing the release dialog, not the trial dialog, and many such things. And when I saw that, then I realized that I forgot to update in certain places. I forgot to update this version information. And I fixed that, and I released to them, and ultimately it was okay. But then I realized why we are changing at multiple places just to have this information. So what I did, I took some 2 days, and I bring all the changes to a single file. So the single file is actually communicating or sending or basically parameterizing other methods or other strings wherever we are using them. So what I did, now what we had is one file in which we had a couple of things to change, and these changes are propagated to the rest of the system. So now if anybody wants to release a new variant or a new version, they just need to change in single file, maybe a couple of variables and a couple of constants, and that's it. I took 2 days actually, and there is no feature addition, there is no bug fix. What was that? That was refactoring. Please understand that there is no new feature that I introduced. From the user's perspective, there is no change. But from the developer perspective, there is a lot of change. Internal structure is changed in such a way that it was much more simpler for anybody to release a new variant or new version. And that's the purpose of refactoring. So this is essentially what refactoring is. And we will so now we are ready to define it. Now you understand what is a typical meaning, but let's take a look at the formal definition. William Opdyke, that was the guy, he actually wrote a thesis, PhD thesis on refactoring, and he actually coined this term, refactoring, and he defined it as behavior preserving program restructure. Similarly, there is another person, very well-known person, Martin Fowler. He has written a very famous book on refactoring in 1999, which is still a bestseller. If you look at on Amazon, it's still is a very popular book. And he defined refactoring as a process of changing a software system in such a way that it does not alter the external behavior, but yet improves its internal structure. Basically, you need to remember two things about refactoring. It's behavior preserving. From the user's perspective, the behavior is not changing. And it's program restructuring. You are restructuring some parts, either you are changing something or you are rearranging something in order to make it simpler for you as a developer. That's what refactoring means. And there are many techniques that we are going to discuss today. Okay? Any questions so far? Yes.
So just to be clear, even if we make like a minor change in the external part of program, like the UI or anything, we cannot call it refactoring in any case.
Yes, actually by definition that's not a refactoring. For example, if you improve the UI, that's an improvement.
Yeah.
Obviously it's an improvement, but it's not refactoring. So we already understood that why we should refactor. That's a simplification process. We are basically carrying out these refactorings to simplify our lives. So it achieves understandability. Whenever you refactor, the aim is to make it a little better for us to understand. It's improving extensibility and flexibility. It's easier to extend, easier to test, easier to reuse. These are some of the advantages that comes with refactoring. One more thing is that, which is many people don't realize, is that the productivity is also affected by refactoring positively. Often. What I mean is that when you have a well-structured software, then it is easier to change, easier to understand, easier to bring new features. At the same time, if you are working on a system which is very difficult to change, if you change here and many other places are breaking, or you, in order to make a simple change, you have to change in multiple places. If you are working with such a software, that will bring a lot of frustration to you, and the morale of the team goes down. And that's why we say that there is a direct link of productivity to refactoring. So you refactor, the productivity goes up. Although you may say that it may take some time. Obviously, it will take time. It will take time depending on how big is the refactoring. If you want to just rename the variable, it's probably a 2-minute job. But if you want to change, if you want to refactor from the architecture perspective, it will take probably a few weeks. So it depends on what is the scale of refactoring that you are carrying out. And obviously, as we were discussing earlier, risk is associated with refactoring. That's why people are they don't go with refactoring, because they say that, okay, it's working now. If we change it, we don't know whether it will work or not. And it is a common case when there are no comprehensive tests available. If you have a big system without very few tests or no tests, then you have to carry out a whole testing cycle, which is probably very expensive. And that's why people refrain from refactoring, okay, don't change anything. If we change anything, we have to test everything again, and that's why, that's one of the fears of not using it or not carrying out refactoring. So let's move on. Now what we are going to do is we are going to see specific refactoring techniques. What are the specific refactoring techniques that, hello, come in. We are going to see specific refactoring techniques. So let's start from the simple one. Look at this method and look at the names. Are these names conveying the right message? Definitely you can understand it if you put some effort, but will it be easier for you to understand this program? The program, the same method on the top, but read it with the meaningful names. And this is the original, and the method in the bottom is the original method, and this is the refactored method. The only change is the above method has meaningful names. Isn't it obvious that the top one is much better and is much easier to understand the top method? Yes? So essentially, you don't have to understand the logic what is getting implemented, for this example point of view. What I want to bring out is that if you have meaningful names for methods and for variable names, it's much better for you to understand what is happening in this method. So this is a simple refactoring which we call renaming variable to more meaningful names, or in short, rename. Rename can be applied on variable name or even method or even class, anywhere, any literal. So as we just saw that if we have meaningful names, it's much better for us to understand the behavior. If you have unclear, meaningless or confusing names, then you will have a hard time to understand the method or the class. And typically what happens is in large companies, they have a coding style. So they define a coding style, for example, how you should name your variables, whether you should be using camel case or not, how the method name should start, whether it should be capital letter or a small letter, how you should name your class name. Similarly, these are the rules that many companies define, and they ask their developers to follow these rules. That's called coding style. Okay, so these rules can be aligned with the coding style followed. Next example, take a look at this. What's happening here? What can be done here better? Seriousness.
Change it to Java.
And they will ask to change it to C#. That's why I have in C++. That's not the point. I'm not giving you how to carry out or how to write a loop in C++. That's not my point. My point is that there are basically two things happening. If you look at here, then the while loop the list is being iterated, and it's, see how we can understand it's a printing out. I mean, it's not like, so we are basically printing the item price, name, and taxes, and then at the end we are printing total kind of a thing. This is, although it's a small example, but you can see in your code or when you will work in industry, at that time you can see that there are methods which are doing multiple things which you can easily split. So this is basically, you can refactor like this, in which you have print all items. So you are printing all the items in this method, and it's very clear for you now that this what this method is doing, because the method name is print all items. So you are printing all the items. And the second method is print invoice object, which is the total. So basically you are printing all the total, what is the total items, amount, taxes, and so on. Isn't it a little better than the previous one? Obviously it's a small example, so you can still say that, okay, I can understand this, I can live with this. That's okay, but the motivation or the intention is that when you have a large method, you need to identify the blocks that goes together and that may be split into separate methods. Okay. So this is basically abstract method refactoring. Another very popular and useful refactoring. What you can do is, what this does is, when you should apply is that when you have multiple responsibilities for a single method, or when the method is quite large, or you see duplicated code blocks, at the time you need to split those blocks into separate methods. Okay? And how are you supposed to do that? What you need to do is you need to identify the block that needs to be split, and you can either use IDE in both. If you are using Eclipse or if you are using Visual Studio, there is a IDE feature in which you can just go to refactoring and then you just say extract method. And before selecting that, you need to select the block that you want to extract. So, for example, you have a method, and you want to create want to perform extract method on this block. So you select this block, go to menu, select refactoring and extract method, and it will be extracted. You need to provide the new name for the method, and then a new method will be created by the ID, and the method call will be placed here. And IDE will take care of the input parameters and output parameters. So it will be easier for you. What you need to do is you need to identify which block to extract. So once you identify that, you select it, go to menu and perform this, and provide a new name for the method, and that's it. It will be there. This is another example. What you can do here? Any suggestion? Yes, please.
Remove the condition and separate method and return
Absolutely. I mean, this is one of the things. Also remember that in refactoring, many times you can perform many refactoring in many ways. So one thing that you can do here is that you can extract this condition and you put in a temporary variable, or much better, even better option is that what you suggested, that you extract this in a separate method, and you call it is item sellable. Basically what you are checking is that whether this item is available or not, and then the required number of units are available or not. So basically you are checking whether this item, whether we can sell this item or not. So that intention, that thought that we can capture in a method name, and we can put it as something like this, is item sellable. and then you call this here. So when somebody is reading this method, then he knows that, okay, what we are checking is whether this item is sellable or not, rather than looking at these conditions. Obviously, if he will put 5 minutes of time, then he will understand what's happening. But you can save those minutes if you just put it as a separate method. Okay? And we call this decomposed conditional. What we are basically doing, that we are these complicated conditional logic. Basically conditional, if the conditional logic is very complicated, then it will become, it's making your code harder to read and understand. And what this refactoring is doing is introducing another layer of abstraction and encapsulating the complex conditional into a separate method. So basically, it's making the method much more readable and much more understandable. Another example. Any thoughts on this? Is it okay? Is it not okay? Anybody?
I think we could change the methods. We could take an input of the case. Instead of calling each time rotate by 90 or rotate by 180, we could take the number and put it as a parameter.
Excellent. So this is precisely is the case here. The method rotate by 90, and there are at least two methods you can see: rotate by 90 and rotate by 180. And if you want to rotate by, say, another angle, say 270, then you have to write, you have to create another method, and you just need to duplicate that logic and maybe just change the angle. Why not you write something like this? You just make angle as a parameter to rotate, and give this angle to the rotate, and then rotate will take care of what is the degree of angle that the method has to rotate the object, right? Your method must be able to handle these inputs. So not only strictly 90 and 180, but it should be written in such a generic way that it can accept any value, any permissible value of angle. Okay? And that's called parameterized method. It's straightforward, and you just need to remove the hard-coded angle or hard-coded value from the method, and you bring that hard-coded value as a parameter so that it's generally used. These are the refactorings, that examples that we have just seen. They are much more simpler and much more local. If you have a single file, you can perform these refactorings in the same file, and the effect and the scope is limited. The effect will be limited because they are, for example, if you are changing the variable name within a method, then mostly only that method will get impacted. If it is a field, then, and especially if it is a private field, then only within a class you may see some effects. Now let's talk about some design level refactoring. And for thinking about design level refactoring, you need to think little bigger. You need to think in terms of objects, classes and their interaction. And you need to have a little bigger picture, how the different classes are interacting with each other. And not only, so far what we have seen a single statement or at max a block of statements. Here you need to think in terms of classes or components and things like that. And there are three stages when we think about design refactoring. The first stage is sense. What I mean by sense is that you need to feel the need that something is going wrong. So, for example, when you are trying to understand a system, you are feeling that this class is doing too much, or this class is interacting, is coupled with other classes too much, or you are getting difficulty understanding something, a class or the relationship of one class with another class. And then probably you need to identify what is precisely the problem. If the coupling is a problem, or it's doing too many things, it's a problem, or what precisely the smell that exists in the code or in this particular context of one class or a set of classes. And then the next stage is that you refactor. You apply a set of transformations, and then obviously you need to take the role of context into the consideration. And what is the role of context? We keep discussing about the context, especially whenever we are talking about design and architecture refactoring. You need to think about the context. I mean, for example, a tool that you might be using a tool, and that tool is saying that you have a design smell in this class. You need to go there, and then you need to take a call whether this is actually a smell which is creating a problem for me, or I have designed in such a way because this is probably the best way to design. And if you change this to, or if you refactor this to something else, then the liabilities will be much more than the advantages. So this is what the context that you need to bring in as a developer, and you need to think whether it is worth to refactor this class. And also there are many design principles. Some of the design principles we discussed, for example, single responsibility principle. You need to keep those principles in mind and then apply refactor. Okay? And let's see a few examples. Take a look at this method and see what you observe here. Any observation?
It could be well, can I say, you want me to stand up to look at the camera?
No, it's okay.
I won't.
No, it's okay.
Maybe the method could be a method of the window object and not the graphic device. I don't think this is the answer.
And why you think so?
Why?
Yes.
Hmm.
Let me tell you,
because
yes, you are going on right track. Please carry on.
Okay. Because there are a lot of methods and properties of the window involved, and the graphic device shouldn't have to know about all this. So it could use the interface and say to the window, get big and get full.
What he said is that this graphic device uses more methods of window than calling its own methods. Think again that there are two classes, at least in this context. One is graphics device, one is window. There is a method in graphics device which is having one parameter window, and all the methods that you see here, method calls, they belong to window class, not the class, the graphics device class. That gives us a hint that maybe this method is misplaced. This method doesn't belong in this class because it's dealing with it's speaking more into the neighbor rather than it's minding its own business. Okay, so that's called move method refactoring. What we can do is we can take that method and put in the right class. In our previous example, we can put that method and put in the window class because that is where the method belongs. We are basically, what we are doing, we are putting apples with apples, oranges with oranges. It's the aim of what we are trying to do is to improve cohesion, and we understood the word cohesion, the meaning of the word, right? Anybody would like to tell me again? What is cohesion?
Apples
Apples with apples.
Greek.
Yes,
Apples with apples and oranges with
exactly. Exactly. Putting apples with apples. That's basically in a nutshell it's cohesion. So we are reducing coupling, improving cohesion, and reducing the size of big class. Many times we can apply new method refactoring when the class size is very big. And typically we call that smell that we just saw earlier, we call that smell feature envy. Feature envy, popularly known smell, because meaning of that smell is that when one class or one member of one class is interested in more interested in other class members rather than its own members. So when that is the case, then we say that it's a feature in the smell, and we refactor this smell with the move method refactor. So we basically move method where it belongs to. And a related refactoring is move field. Many times these are carried out together. So if you move a method, many times it's also required to move a field to the same class typically. And what is the mechanism? It's very straightforward. I mean, you need to identify first that which block or which method that belongs to some other class. Then you create, if it is the whole method is moving, then you need to move the whole method, and then you need to changes accordingly. If, for example, if this method is accessing any variable from this class, then you need to adjust. Adjust in the sense either you split that method into two methods and only move the part which belongs to the other class, or sometimes you make a method call from this class to the other class and still use the method. And obviously look for parameters, what parameters should go in and should go out, when especially if you are calling from this class or that class. If you are creating if you are putting a method call, if you are moving a method and then putting a method call in the original class, then you need to take care of what parameters should go in and come out. So the consequences are that we will hopefully get a cohesive smaller method or class. And typically it is carried out in groups. So when you move one method, typically it is the case that you need to move another field or another method. That's the typical case. Let's talk about this new example. Small class with a few methods. Anything that you observe here? Yes, please.
Insurance could be in another class.
Yes. Very good. Excellent. Basically, the car class, the name of the class is car. Obviously, car may have insurance, but it need not be in the same class. These are two different aspects. You may have the car must be start and stop. This is the behavior part of the car. But when it comes to insurance and whether it's insured or not, and these are the details which must be separate from the car or class itself. So it can have a relationship with the insurance policy or insurance class. The car class may have that association, but it is not really a good idea to put everything related to car in a single class. And when we see that, then we can refactor this kind of a class with abstract class refactoring. So what we are doing, we have one class which in which there are some methods and fields that can go to some other class. So what we do, we identify those parts in the sense those members, whether it's a method or it's a fields, and then we create a new class and put that these methods and the fields in the new class, or we identify the existing class and we move the fields and methods there. It is also often the case that insurance class might be existing already. So if it is already existing, then we just need to move the corresponding methods and fields to the proper appropriate class. If that doesn't, if it is not existing, then we need to create a new class, say insurance, and then put everything there. And relate this car class with that insurance. Basically create an association between car and insurance. And why we are doing, basically we say always that we were discussing single responsibility principle some time back, which is also is saying that we should have a unique responsibility for each class. So similarly, whenever this single responsibility principle is violated, then we apply this abstract class refactoring. And if you have taken a look at these posters, we have one smell which is called multifaceted abstraction. That the smell occurs when a class has multiple responsibility assigned to it. So essentially what example we have seen, the car example, is basically a multifaceted abstraction. So that abstraction has multiple responsibilities. And by applying abstract class refactoring, we are splitting the classes and we are trying to follow single responsibility principle. How we should do that? We need to identify what are the members that needs a separate class. So we identify these methods and fields. We move them by applying move method or move field to a new class. If the new class doesn't exist, we need to create it. If there is already a class, then we need to move that class and those fields and methods to that class. Obviously, establish the relationship. As we just saw that there must be an association between the new class and the existing class, and then obviously compile and test on that. And the consequences of this refactoring is that we improve cohesion and coupling measures, and it may break client's code. What it means is that if there is a client which is using the older class, for example in our case car is a class, and there was a client which is using this car class, and if we split this car class into two and assume that that client might be using for example get insurance details, so that in that case the client code will break, because now there is no method called get insurance details. So in that case you need to, when you refactor that, then you need to take care of that call also. Then maybe you need to either, there are many ways to handle this situation. Either you create a dummy forwarding method in the car class, you still have the method, but you just pass that, you call that the method from the insurance class. So for example, if you have the method, still have this method, get insurance detail, but you don't have any insurance detail, you just have insurance object. You call that insurance object, get the detail, and whatever is returned from the insurance object, you just return back. That's a forwarding method. That is one way. Another way is that you can introduce a new method, say method or a attribute or here in the car, say insurance. And then, or you can have a new method called get insurance object or something like that, and you can get the object from car class, and in the client, once you have this object, then you can call required, method. So you can say get insurance detail or who is the insuree or whatever. So that's the example what may happen when you refactor at a little larger scale. So when you are refactoring in a smaller local scope, for example within a file, then the impact is not really visible outside this scope, outside this class. The moment you start performing design refactoring, which may impact its clients. So not only you need to take care of the local association relationships, but also who's calling this method or this class, who is the user or who is associated with this class. You need to take care of those also. Okay. There are many other classes, other refactorings. For example, the renaming we already seen, split temporary variable. So what happens is that if you are using temporary variable, so temporary variable name, say any name, and then you are using it somewhere, you are computing somewhere, for example, you are printing the value of that, and then you are still using it again for some other purpose. So basically you normally don't use a same variable for multiple purposes. So if you have to use it variable, then you give a proper name and use one variable for one purpose. Don't reuse the variable in a single method. So for example, you have an area variable. So first you calculated the area and then you printed it, and then it's done, right? So you can use it for volume. So instead of renaming and having a new variable called volume, you are still using area, but you are calculating volume. That's not a good practice, because the person who is reading it, he'll say, oh, why we are printing area 2 times? Okay, but actually you are not printing area 2 times, you are printing area once and then volume in the second case. So basically that's the split variable, split temporary variable. So you need to split those, you use 2 separate variables. Consolidate, duplicate conditional fragments. It's like if you have a if block. So if the condition is true, then a certain block is getting executed. In else part also you have a block, a set of statements, and some of the statements are common. If that is the case, then you don't have to duplicate those. For example, even 2 statements, those are common in both the cases. In both cases, either the condition will be true or false, right? So either this block will get executed or this block. So why not you put these common statements outside this if statement?
Above.
It depends. If it is the common statements are in the top, then you put those common statements first and then you check for the condition. If it is in the bottom, then you put it in the bottom after the if statement. Extract class, interface, method, package, that's a whole family of extract. So we have seen extract class, but similarly you can apply extract interface, in which you actually you create basically a new interface. You can also extract a method, package, subclass, superclass. So depending on the context and what you precisely want to achieve, you can apply one of these. Form template method. It's a template method is like you are creating a template of a template in the sense a few steps. For example, if you want to retrieve customer details, and for example, you need to print it on, say, in a log file. Just an example. So there are a few steps that you need to follow. For example, your first thing is that you need to establish a connection to the database. That's the first step. And if it is successful, then the second step is that you file a query. The third step is that you close the connection. Log do whatever you're supposed to do and then close the connection. So that's a set of steps that is there. and which is applicable generally for any customer or any similar queries. So you define a template, and all the subclasses basically may follow the same template. Obviously, they may differ they may pass a different query or different selection criteria, but otherwise the steps are similar. So you basically define a template and you follow the template in all the subclasses. So that's called introducing template method.